do what's called rationalizing the denominator. So as you can see, we have a square root on both the numerator and the denominator. So they're separated out, but you can't leave a denominator with a square root symbol. So what we do need to do is get rid of that. Now, if you've seen some of the earlier videos where I have a pair of radicals of the same, every time you multiply a radical with the same number, it's going to basically keep the number the same. So if I multiply by 6, square root of 6, square root of 6 times the square root of 6 eliminates the square root symbol, and it just leaves the number that we have under it, which in this case would be 6. Now I can't, of course, do multiplying in the bottom. I have to do the top as well. So these can be multiplied just like you normally would. 1 times 6, which is going to be 6, and that's the square root of 6. Then down here, like I said, these two have a pair, and since it's a pair, the symbol of the radical will disappear and the number that's under it stays the way that it is. So this would be your simplified version of the fraction without that square root symbol in the denominator. Let's take a look at one more right here. I'll do these two. So we're going to take the same thing. In order to get rid of the radical symbol, we're going to multiply it by itself, square root of 3, and we can't just do it in the denominator. We're going to have to do it in the numerator as well. This and this is a pair, so the denominator will just be 3 because the root will cancel. And then here we can multiply normal, 5 times 3, so you get 15, and the square root of 15 over 3 would be my finalized simplified fractional answer. Now, if we take a look at this last one, you can break these down just like you had them up here. So like you can put the radical symbol on both the top and the bottom on both of these problems. But what I'm noticing on this one in particular, just like normal fractions, if you can cross simplify. This square root of 4 right here can cancel out this square root of 4 down here. And that's just going to make 1. So I'm just going to put 1 here, and I'm going to put 1 here. So what that ends up leaving me is the square root of 3 on the top with the square root of 5 on my denominator. And similar to the one I did up here, it's just the reverse, I'm going to multiply by the square root of 5 in both the numerator and the denominator. The denominator is going to cancel that root symbol, leaving me just with 5. And then I multiply these two like I did with the top, the one above it. And 5 times 3 is 15. So it's the square root of 15, but this time it's over 5. If you want more questions like this, like I said, found them on my YouTube channel, my Instagram, and my TikTok, YouWantAlgebra. These will all be found in my root playlist that I have. Thanks for watching.